All right, guys. Let's go ahead and get started. So, lesson 5 for the first unit is calculating measures of center and variability. So, we're talking about measures of center such as mean, and I apologize, I left my stylus at school, median, and mode. And I've got this one at home, but it's not very good. So, we're going to give it a shot. All right, so the first thing I want you to do is just take a look at these first 4, and what I want you to do is pause the video and either talk about it with a partner that's close to you, or just kind of look through. But what you're going to look at is, are each of these first 4 examples true or false? Okay, this should take you probably about 3 to 4 minutes, depending upon how quick you are at calculating averages. Right. So go ahead and pause the video now. I'll wait. Okay. All right, so let's go ahead and check your answers. So within the first 4, if you pause the video, the question was, the mean can be found by adding all the numbers in a data set and dividing the numbers by the numbers in the data set. So it's saying, let's say we have 1, 3, 5, 7, 9, right? Well, since those are 5 numbers, we can add those all up, and instead of putting commas, 1 plus 3 plus 5 plus 7 plus 9, and then divide it by how many numbers there are. In this case, there are 5 numbers, right? So is that the way that we find mean? Yes. Yes, it is. So this would actually be true. Okay, so hopefully you got that one right. Okay, second one says the mean of the dot plot is 4. Well, just like the top, this is organized a little bit differently, but it's the same idea. We just want to find the mean. So we're going to take all these numbers. In fact, remember that these dots represent the numbers on the bottom here. So we have a 1. Oops, sorry, I'm trying to write this out, but again, my stylus is not working correctly. 2, 3, 3, because there are 2 dots on the 3. 4, 4, 5, 6. Okay? All right, so we go ahead and add all these up. We got 3 plus 3 is 6, plus 3 is 9, plus 4 is 13, plus 4 is 17, plus 5 is 22, plus 6 is 28. So that's 28. And there are 1, 2, 3, 4, 5, 6, 7, 8 different dots. So 28 divided by 8. Some simple math tells me that that is just not true. 28 divided by 7 is 4. So this is actually a little bit less than 4. Okay, so that tells me that this one is actually false. And again, I apologize for the handwriting. You just have to bear with me today. I'll try to do as best I can. Number 3, the median. Remember that median means middle of the data set is 9 for the data. So if you look at these 5 numbers right off the bat, you'd be like, yeah, number 9 is in the middle. However, it's not in chronological order or numerical order, excuse me. So let's rewrite that in the appropriate order. You got 1, 4, 5, 9, 10 from least to greatest, which means that 5 should be the median. So this is also false. You can only find the median when it is written or represented in a way that is from least to greatest. Okay. All right. Number 4, the median of the dot plot is 3.5. We've done this a couple times in class. This is just where we're canceling things out and trying to find the middle. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So that tells me there's an even number, which means that number is going to be between these 2, which are 3 and 4. If you add those up and divide by 2, right, because there's 2 numbers, that is in fact going to be 3.5. So this is actually true. Okay, so hopefully you checked with a friend prior to doing this and actually paused the video just to assess what you do and don't know. That mean, median, mode is something that you were supposed to learn previous years, but that's okay. We're just going to review it in today's lesson. Okay, 5.2. So the heart rates of some high school students are listed in beats per minute. Okay, and these are actually pretty legitimate numbers here. More like resting heart rate, but still. So it says create a 5-number summary for the data above. And as you can see, I've already written these out in the correct order. So again, pause the video, make sure we do that. Okay. Now that hopefully you've written that out, paused it, now we can identify those 5-number summary in case we wanted to do a box plot. Oops, I just recognized a mistake. This is supposed to say Q3, not Q2. Okay. So what would the median be? Well, let's go ahead and count it out. Bam, bam, 1, 1, 2, 2, 3, 3. And then we got 2 numbers in the middle here. So since they're only 1 apart, we can just go up by a half, right? Half of 2 or half of 1 is just 0.5. So we're going to add 0.5 to the bottom one here, and that's going to give us 76.5 is our middle number. Okay? You remember how, of course, how to find min and max, or should. Min is always going to be the smallest number, which up here, some of these may be hard to find, right? We don't, because it's not written in the correct order. So always make sure to write it in the correct order when we're summarizing the data. Then the max is 81 after I rewrote it. So now we've got 3 of the 5 summary points. We just need quartile 1 and quartile 3, which if you recall, we find those by going to the center, which in this case, we already said that our center was somewhere right here. So I'm going to draw a line there. And then calculating the median of that. Okay, so we got 72, 76, and then we've got, again, an even number, but thankfully they're only 1 away from each other, so we just go halfway between that, which is 75.5. Okay, and then quartile 3, same idea. So they're up, even number, so we take the 2 middle, find the average of them. In this case, is 78.5. I'm going to try to write with my finger instead because the stylus sucks. Okay, so mean, median. There's a quick review of how to find those. Now we're going to find some other things like interquartile range. Okay, it seems like a pretty big word. We often refer to it as IQR. In math, we like to abbreviate a lot. So if you see IQR, that's what we're talking about, interquartile range. It's basically just taking the range of values from the middle half of the data, or where, if you recall, last week we talked about a bell curve. So usually the interquartile range is in here, which means this is most of the data, right? Outside here, like outliers, or let's say you take a test and somebody gets 100%, but everybody else scores in the B and C range. Well, that person out here is C, is up there. Somebody does really poorly, but they're not the best representation of the entire class, right? Most of the class is in this data if you have a bell curve. So we want to look at interquartile data because then we can identify like where is most of the class at. So if most of the class has like a D on a test, well then as a teacher we have to look at that and say there's probably something else I should be doing to make sure that I bring that part up to a B and have a lot of people with an A and maybe a couple with a C or a D, right? But our goal, you know, let's say that you start a company and let's say you're a mechanic. Like you want the majority of the people that you, the customers that you have to be in here in terms of their satisfaction, right? You're going to have some that love your company and you're going to have some that maybe something went wrong and they hate it. But you're not going to be a successful company unless you have the majority of people in here that you've helped out. So what is interquartile range? We just described it up there, but we're going to take quartile 3 and subtract quartile 1. So in this case, we're going to take 78.5, okay, and we're going to subtract the 75.5, and again, those things are coming from up here, 78.5, 75.5. Okay, so 78.5 minus 75.5, which is 3. So our interquartile range is only 3, whereas the range of our entire data would be 9, right? If you go from here, subtracting there would be 9, which is a much bigger range. So interquartile is a more focused range, is what I like to call it. So it says how many values in the data set are less than quartile 1. Quartile 1, if you recall, is 75.5. So there are actually 2 that are less than that. how many are between quartile 1 and the median? Well, the median is 76.5, and quartile 1 is 75.5, so there's going to be 2 here. Between the median and quartile 3, we got median is here, quartile 3 is here, so we got 2 there. And then greater than quartile 3, and there's going to be 2 there. Remember, we had 8 data points as well. Okay, that's not always going to be the case. A lot of times it's going to end up being like 1, 4, 5, 2, or something like that, where these outside ranges are a little bit smaller. Anyways, I digress. Let's move on. Number 3 says a pod of dolphins containing 800 dolphins of various ages and lengths. The median, again, middle length of the dolphins in this pod is 5.8 feet. What information does this tell you about the length of dolphins in the pod? Well, since the middle is about 5.8, that tells us there are no dolphins, we would assume, at like 100 feet long, right? So, but that's not really a good analysis of the data. What we could say is, since the middle is about 5.5, we could say that we could assume the dolphins are around 6 feet. Okay. We might even be able to say that they're somewhere between 1 and, I don't know, 10 feet, right? Like somewhere between there. Okay, so by us knowing what the median is, it gives us a closer summary of the data. Number 4, the same vocabulary test with 50 questions is given to 600 students from 5th to 10th grades, and the number of correct responses is collected for each student in this group. The interquartile range is 40 correct responses. Okay, so what that's saying is, remember, if you think about the box plot, all right, we have the median, and then we have quartile 1 and quartile 3. And then we got the range. So this is saying the interquartile range is 40 correct responses. Okay. What information does this tell you about the number of correct responses for students taking this test? All right. So it's saying the people that went in through here, that range is about 40 questions. Okay. So that's saying that most scored around a B or a C. Because 40 out of 50 is 80%, which is a B minus. So we would think that most people scored like somewhere between like 70 to 90, right? 90 being an A minus, 70 being a C minus. So my guess is that interquartile range, they're probably going to be around, a B or a C average. Okay, it says, what would a box plot look like for the results of this vocabulary test? Obviously, we just kind of looked at that. What does the interquartile range tell you about the data sets? Any interquartile range tells you like a more focused range. Okay, it's not talking about the outliers. It's not looking at the biggest or smallest numbers. It's talking about where is the meat of the data, if you will. How do the median and quartiles divide the data? The median is like the 50-50. So 50-50. Whereas the quartiles, like, those kind of split it. So this is 25%. This is 75%. Usually. Okay, so there's about 50% of the data right there in between those two. Okay, and it says how much data is between quartile 1 and quartile 3. It's about 50% of the data, usually. Okay, all right, we're going to move on to the last thing here for today's summary. Okay, this is something that was added to the curriculum this year, so it's a little bit more complicated, and I understand if it doesn't make sense fully, but let's get into it. It says the measure of variability determined by the mean of the distance of the data points from the mean of the distribution. This is called mean absolute deviation, all right? So average absolute deviation. Deviation means like how much it's different than the normal, Okay, so let's say, well, we're just going to go through an example here. It says, calculate the MAD using the same data from the previous activity by finding the average distance from each data value to the mean. So we're going to find the MAD. We're going to find the MAD of this data. All right, so same data from earlier. Now, here's the thing. I've got to find the average first. So I'm going to use a calculator here because these are bigger numbers. So I'm using decimals. 72 plus 75 plus 81. And I'm just adding all these up. 76, 76, 77. Oops. 79. Dang it. Plus 78. Okay. And then I'm going to take all of that. So 614 is my response. 614. I'm going to divide it by how many numbers there were, which we already know that there were 8. Okay. So that tells me the average of this data is 76.75. Okay. All right. So 76.75 is the mean. All right. Now, I would fill this whole chart out, but I'm just going to copy this down, right? Just draw an arrow because the average for the whole data is going to be the same. So now I'm just subtracting. So in this case, I want to subtract, 72, the data value, minus 76.75. And that is going to give me a negative 4.75, which again, you could easily use your calculator for this. So the absolute value, if you recall, the absolute value of any number is just a positive version of that number. So since this is negative 4.75, we're just going to list it as 4.75. All right, we're going to continue to do the same thing, right? 72 minus 76.75. So if it's 75 minus 76.75, because that's the next number. We're going to continue to do this and find our absolute value of deviation for each one. So this is negative 1.75. Let's see, 81 minus 76.75. Okay, well, that's going to be 4.25. Right, let me think. 81 minus 4 gets me to 77. 77 minus 0.25, yeah. Okay, so 4.25. This one is 76 minus 76.75, which means it's in the negative. So negative 0.75, which means this one's the same one. This one is 1 bigger, so this is 77 minus 76.75. Which is 0.25. And then this is 2 bigger than that, so 2.25. And this is 1 less, so 1.25. Okay, so now I'm just going to list down the absolute values. So again, positive versions of these. Even if they're already positive, you leave them as positive. So 4.25, 0.75, 0.75, 0.25, 2.25, 1.25. And again, if I'm going too quickly, just pause the video. Make sure you get these all copied down. So 4.75, and you can see all my numbers are now positive. And the resting heart rates of students, it looks like the biggest difference is 4.75 right now, right? Okay, so now what we're going to do is we're going to find the average of these numbers, okay? And it's going to tell us the average deviation for one student, okay? So 4.75, oops. Okay, plus 1.75 plus 4.25 plus 0.75 plus 0.75 plus 0.25 plus 2.25 plus 1.25 divided by 8. Oops. So 16 divided by 8, of course, is 2, right? So that means that if our average heart rate is 76.25, okay, 76.75, and that average deviation is 2, that means that most students are going to have a heart rate between, so somewhere between 74.75 and 78.75. Okay, so here's what you could do to check your own heart rate. Put your hand on your wrist, put your thumb on your wrist, on the inside of your wrist if you choose, or on your neck. You're going to start a timer for 60 seconds. You're going to hit start, and you're just going to try to focus on counting how many times you feel your heartbeat. And it should be, if it's a resting heart rate, according to this data, should be somewhere in there. Okay, somewhere between, 74 and 78 beats per minute. Okay, all right. Lastly, let's look through it. 2 more examples here. It says for another data set, all the values are either 3 beats per minute above the mean or 3 beats per minute below the mean. Is that enough information to find the MAD for this data set? If so, find the MAD. If not, what other information is needed? Okay, so this says all the values 3 beats per minute, or 3 beats per low per minute, right? So could we find for all the values are either 3 beats per minute above the mean or 3 beats below the mean? Okay. Well, I mean, so that's probably kind of easy to figure it out, because then you're saying, well, I'm going to add up 3 on the positive side, and I'm going to add up 3 on the negative side. But remember that we need the average deviation, so that's going to be 3 plus 3, and then divide by 2. So that's going to be 6 divided by 2, which just tells you that the average deviation is about 3, right? So because you have 3 on the top side and 3 on the low side, this is not that difficult to figure out the MAD because it's an even number. But if you want to find a more specific number, you need to know what is that data set's average, and are we saying that this is the average of the upper and the average of the lower, or are those exactly the same, right? And I would think that since we're talking about human beings, there's going to be some more deviation there. Several pennies are placed along a meter stick, and in position of centimeters of each penny is recorded. The mean position is the 50 centimeter mark, and the MAD is 10 centimeters. What information does this tell you about the position of the pennies along the meter stick? Well, it tells you, since the mean is at 50, right? So if this is the stick and it's at 50, well, the MAD is 10. That tells me that those pennies are going to go between 60 and 40. They're going to be 10 on either side. That's what that tells you. Okay? All right, so this is kind of a long lesson. I know I made you pause a couple times, but here's the summary. Today we learned about MAD, or mean absolute deviation. We learned about the interquartile range. We talked about mean, median, mode. I even wrote down again how to calculate MAD, how to calculate interquartile range, and obviously you should know how to calculate mean, but if you need a refresher, it is that very first one up here at the top. You add all the numbers up and divide by the number of data points, okay? So I'm going to end this, the video now. You guys have some practice problems to do for homework. If you have any questions when I get back tomorrow, we'll start with that. See you then.